are live with three of my close friends, Dewey Nielsen, Dr. Michael Chivers, and John Quint. We were just having a discussion because we've been traveling now for a few months with our new internal strength model, the FRS ISM. And I thought we would get together and discuss topics regarding strength, regarding the programming of specific strengths for athletes and what that means. And more specifically, I suppose I wanted to discuss where we thought there may be areas to improve what we refer to as the standard model of training, which is the model that is, that we categorize that is used by everyone at this point, and where exactly did that model come from, and how did we feel like improvements could be made, or what have we been doing perhaps differently with our athletes to try to further that model and to make improvements wherever possible. So I guess just to start, because people always consider that the model that is currently being used has always been there, like rarely do people consider that there's a start point where someone had to think of what does strength training look like? How do you categorize strength training? How do you push certain qualities in athletes to make adaptations? And I think that what we've learned in traveling with this ISM is that a lot of people tend to think that these concepts have always been in place or that they were inherent, when in reality, a look into the history of strength training tells us that all of the things that we consider to be normal strength training things, like squatting and deadlifting and hack squat and this kind of squat and bench press, etc., these were all constructs that were created for particular reasons. And as we argue in the standard model, which is the model that people use, people tend to select from these exercises that were given to us or handed down in this standard model of strength that we've inherited, with the belief that that's all there is. So I guess the first thing I want to ask, and I'll point this at Quint, is can you outline just briefly, I know that you can go on for a long time about this, but the history of where traditional strength training modeling began and where we're at now, kind of bring us up to this point?
Yeah, so that's one of the things that we did in the model, where essentially we had to look at like the evolution of strength and strength training. And what that did was it forced us to really coherently understand that the model is quite new. Like the first time systematic strength training occurred was realistically in the Soviet Union. Prior to that, there was no systematic training. Okay, what I mean by systematic training is constraining training to acquire very specific things. So the Soviets were the first to do that, realistically in regards to absolute strength as well. So what we figured out from what they did was essentially there was 4 methods of strength training. You got maximal effort method, dynamic effort method, repeated effort method to failure, and then repeated effort method not to failure. And it's quite interesting because when you delve into the manuals that they had, like all the Soviet sport reviews, even the manuals that like Medvedev and all the actual top coaches wrote, you can kind of see that realistically, they kind of figured out that everything that you're doing falls into one of the 4 of those methods. And their realization of that is what enabled them to start to program specifically those 4 methods. And then they started to figure out they had to program those 4 methods in parallel with one another to elicit cumulative multifaceted effects. And from that emerged the conjugate sequencing system. Then from there, the introduction of that system into the West was done through Westside Barbell and Louis Simmons. And so, so when you look at the timeframes of that, though, you can kind of see, I think that's one of the biggest things to take from that lecture. And you guys, correct me if I'm wrong, was we see that like in regards to specific strength training, not just generalized training, GPP, in regards to using training in a very specific means to acquire very specific physical capacities, traits, etc., that we're kind of new in this whole entire thing, right? So you figure, let's say 1950, because that's the first time that they competed in the Olympic Games. If you go 1950 to when we did that, you know, that's only 70 years. If you look at that in relation to other sciences, that's almost no time at all, right? So I think one of the big things to take away from that lecture is just a simple fact that we understand that strength training can be constrained. We understand that strength training can be constrained and then programmed over time to acquire very specific things. But all of that stuff happened at the external level. And a lot of, I think, strength coaches haven't decoupled that to understand that when they were training, and when I mean they, Soviet Union, West Side Barbell, they were training for a sport, whether the sport was Olympic weightlifting or powerlifting. And I think one of the things that we had to do that made it very difficult was to uncouple sport or that skill from the training of actual strength.
Let's start unpacking that. That's a lot of information. So in terms of timeline, you said it briefly there. You're talking somewhere in the 1950s, right? And what you're referring to there is the specific application of sports science to the development of specific strength. So just to give people context, we're not saying that strength training, of course, hadn't been done prior to that in the history of human civilization. But what we are saying is that marks the first time where the scientific method was rigorously applied to a group of humans to determine what type of methodology produces the greatest amounts of strength. Is that what you were saying?
Yeah, 100%.
And with regards to that, I think another thing that we should discuss is the importance of the type of research that the Soviets were doing there and what populations they were doing it on. So in terms of these, in terms of this application of strength science, this would also be the first time that it was applied specifically to the higher level athlete.
Yeah, yes, 100%. So the Soviets had a whole system. You know, it's called the PASM, Process of Attaining Sports Mastery, right? And obviously that happened because, you know, they were a communistic state and they were able to select specific athletes, but then rigorously test those athletes. And then they had a system within there where each athlete was at a certain level. So then they would see that, like, you know, for instance, you know, Medvedev discusses how, you know, if you're to make the USSR Olympic team, you got 7 years of prior training before you can attain that high sport mastery. So they really did have a system, and that's the reason why they produced systematic results, no different than West Side Barbell. Yeah, to directly answer that question, what you see is they had a specific aim in mind for the training, and they constrained the training for that specific aim. What a lot of people, I think, don't realize is, like, if your aim is, let's say, NFL football, NHL hockey, like, you have to do what the Soviets did instead of just trying to copy and paste that same program. You have to understand the difference between training for strength, right? And then training, you know, preparing the athlete to have physical capacities for skill acquisition.
Okay, and in that, we also kind of made this distinction between, sorry, going back to what I was saying before, the fact that they did this research on these high-level athletes, and maybe I'll shoot this question over to Mike. Why is that an important concept to really emphasize, that it wasn't general population? And I'll preface this by saying, I mean, you never meet a trainer who says that, you know, their methods are terrible. Like, I've never met a trainer. Hey, how's it going, man? I'm good. What do you do? I'm a trainer. Do you do good work? No, man, my stuff is terrible. Nobody ever gets stronger. You never hear that, right? Which means that there's certain levels of strength acquisition that are different when dealing with a general population versus dealing with these higher level athletes. Can you speak to that?
In that general population, anything will work. Is that what you mean?
Is that, yes, I guess that's pretty much what I'm saying, because there's a difference between, you know, with regards to strength training, and because it's such a new science, so to speak, the science of sport training and science of strength training, the way that people assemble exercises, I don't want to say it's random, but I do want to say it's kind of piecemeal, right? And of course, if you apply any type of programming to a general population, as you say, anything would work, which might then confuse the profession in general into thinking, that everything works, which is another way of saying nothing works.
Of course. Yes. Yeah, I mean, I don't really, I mean, it is what it is. I don't think we have to get into super duper specifics, but I mean, when you look at research in anything, whether that's strength training or in our world, like therapy endeavors, the more general the population, the more they will respond to general inputs. The more specific the population, the more specific the inputs have to be to create any sort of change, just because that's the way that the system works. So if the system doesn't have anything that can direct its behavior into certain patterns, then general things are going to work for the most part. But if the system already has specific ways of doing things, then that is more ingrained. So to really create change, you're going to have to push specifics and target specific resources within that system to try to make that system move out of that current patterning. So I think that's the importance of that. And so really with that Soviet research being on athletes, you can see the specificity that they were trying to create within that research. Whereas I think what you're trying to say is that most people are taking that and applying it generally to general population and saying, look at the results I'm getting, without really understanding why. And I think that's a big question that we've kind of through the years have asked a lot of people. Like, I think when you have success, treating clients or training clients, a lot of people don't ask, why am I having success I'm having? A lot of people just say, oh, well, as you said, they say, well, I'm doing great. I'm achieving what I want to achieve. But nobody really asks, why am I achieving what I'm achieving? And how am I eventually going to change this to achieve more? We have this whole notion that you're only supposed to learn from failure and like what you don't achieve. But I think there's a lot to be learned in what you're achieving as well. So again, if you're applying general training stimuli and you're getting results, you have to figure out why you're getting results, because that's the only way that you're going to change how you're going to get those results in the future.
You know what? I want to pull Dewey into here just from a specificity standpoint, because I'm sure you can relate this to something like the martial arts in Jiu-Jitsu, in your case, Dewey, in that, when white belts and blue belts are rolling, there could be the argument for an observer that almost anything will work, as long as you do it vigorously enough. But that's why they say you don't really start learning until you become a black belt. Obviously, meaning that at that point is when you really start to determine whether or not things are working. And that's, I want to bring this up because I don't think we're saying this to be negative, but I think what we try to do with our ISM and what we try to do when we teach is to find that boundary, as like you were saying, Mike, as to what is actually causing the change. Not to say that general strength training for health is a bad thing, but in our world, where of course we're asked to defend our theoretical constructs, I think we're just trying to work at that level of the top of the top, so that the signal to noise ratio works more in our favor. I think that's what we're trying to say there. But I mean, if we bring ourselves up to the current phase, first of all, going back, I think that you said, John, something about external training and the fact that if you look at this historical perspective, the things that we have inherited as being traditional strength training methodology, or what we call the standard model, were really things that were inherited by people who were trying to achieve a particular outcome in the external environment. So maybe somebody wants to discuss that difference between what is internal and what is external, and how this historical construct has really focused us into one of those realms, being external. I guess I can.
Yeah, I think that's a really good point. And I think, it's interesting, like Chivers is talking about like feedback mechanisms, right? So think of it this way, in the Soviet system, what they would do is after each Olympic cycle, the cycles would get published. So you had a 4-year training cycle would get published to get scrutinized among coaches, right? And so when you start to think about, like, that's the reason why they had those feedback mechanisms in place. But another interesting thing, and I think that's what we want the model to be used for, right? Like when you look at the feedback mechanisms in the standard model, it's all based off of external behaviors or feats of strength, which starts to become an issue because the feat of strength isn't what really the internal model's after. The internal model's after trying to acquire things on the internal side. You see what I'm, and so it's like this, you know, think about it this way, you know, because here in the West, we really haven't training, because the training has been all almost randomized. You know, think about NFL guys or football. Like, try to get your hands on any type of research regards to what these universities are doing, and there is no research. So we don't really even have a feedback force to go back to individuals or systems are willing to actually post what they were doing, so then we can scrutinize them and we can see, hey, they're using this method to acquire this patient. And then that's how the system, those are the feedback mechanisms that start to enable us to learn from that system of how to program over time. The reason why I'm saying this is because the volume problem that you see, right? So for instance, I ask lifters this all the time, you know, because I work at West Side Barbell, and I'll be like, you know, you see the volume of these guys doing work, and they go, okay, well, I have to be doing this volume. But what they don't understand, and the simple question that I ask is, I'm like, listen, you guys aren't understanding that powerlifting is a sport. So when do the powerlifters practice? They don't, they merge the two together. Mm-hmm. Does that, you see what I'm saying, right? So if you start to think about it and you go, well, I'm not a powerlifter, that's not my sport, but I want to use this mechanism that is training, specifically strength training, to acquire the same capacity, some of the special strengths that the powerlifter has, then you realize that you immediately have to reduce the volume, because you have to do that type of volume for your skill work. Does this make sense?
I think, again, we have to try to unpack this even further. So what you're saying is that, well, going back again to this historical perspective, the things that were being trained for were specific to the specific sports that they were using the training for. So Olympic lifting, powerlifting. So things like a deadlift, things like an Olympic lift. Nowadays, they'll take something like Olympic lifts and people will consider this to be a quote unquote power exercise. And then, of course, we pose the question, well, power is not a universal thing, right? You can't do a particular exercise that bestows power upon you, because power is the use of force in a very specific context. So I think I want to really get to the heart of that idea that nowadays, when you go to any gym, to a university gym, and they're selecting exercises, the pool of exercises they're selecting for were developed for the specific reason to increase the special strength that is needed to be a Olympic lifter or to be a power lifter. And I think that's where we feel like the standard model is overly generic, in that you're really teaching the person's body to get good at a particular something, at an accumulation of movement variables into this emergence of movement that is the Olympic lift. And that in time, what we've realized with our athletes is that if you hone people into these specific external feats of strength, you do so by paying a penalty to the actual system producing this external feat of strength, which brings us to this concept of internal versus external. And Dewey, maybe you want to give us that general definition or concept as to what it means to concentrate internally versus what it means to concentrate externally.
I think from the get-go that the target is a missed target, because the target in the standard model is to essentially get better at the exercise. Like, okay, I added this much weight to the bar, or velocity is going up, where internal model is specifically saying, maybe I want to add mass right here. Maybe I want to add red tissue right here. Maybe I want to increase load bearing capacity of my connective tissue here for the goal of whatever the external goal is, such as a sport. So if it was a martial artist, and I'm looking at trying to absorb force on my elbow to buy time to fight out of an armbar, I can specifically, with the internal model, put load bearing capacity here to buy myself time, rather than the target being, let's get better at the exercise. And I think that stems even further nowadays with movement assessments. So people start the assessment with, I want to see what looks good to my eyes on what their movement is. I'm going to score you a number for your squat. But how was that squat executed? We don't know how that was executed internally. So it told us nothing about the internal environment. So I think the target is wrong from the training perspective and from the assessment perspective, and going all the way back to what John's talking about with the Soviets and somewhat the creation of the standard model. Our target is a little bit wrong.
And this is something that we tend to see on a live basis with all of our clients and all of our athletes. And I think one of the reasons is because we're consistently running what we call FRAs. So for people that don't know what FRAs are, maybe Mike can give us a brief overview as to what FRAs are. And the reason I bring this up in the context of building strength is that it's very easy to see when you're tracking an athlete in the specificity that is tracked during one of our standard FRAs, in that we're checking all of their articulations. What are they capable of? What are they not capable of? And we're doing so over time. It's very easy to see that when you implement standard model training for the purposes of getting better at feats of strength, I want to be a better deadlifter, or I want to be better at squatting, or I want to bench press more. If you're reading the capacities of the individual who's going through this program, it's very easy to see that when you concentrate externally over time, the internal measurements, they go wrong. They become more molded, integrated. So maybe you can speak to that, Mike.
Yeah, before we do that, I think I wanted to touch on something that John said, and that is that when you look at the external model or standard model training, he said something that I think that is important to touch on briefly. He said that the training and the skill went together. So the training of powerlifting is a skill in and of itself. So there's a meshing of doing the skill and training at the same time, which doesn't exist in other sports. So when you look at that lifting as a skill, the uniqueness of that is that it's a closed skill, right? So it happens in the same environment all the time. It happens, the setup is the same, the rules are the same. So there's nothing else that you have to prepare the athlete or the system for in a closed skill. So you can easily mesh the training and the skill into one session, but that's not how it works in other sporting environments. All other sporting environments, you know, coming from a jiu-jitsu background or football or hockey or whatever, they're not closed skill. The rules are the same and they govern the play of the sport, but the situations and the context of the sport are always dynamically changing. So when you think about it that way, training in a closed fashion to improve a skill that exists in a closed fashion, you can see that it doesn't really transfer over into open dynamic skills, which most sporting environments are. So I think that's an important point that I wanted to touch on, and why the internal model is what it is as well, because what we've done is we've tried to say, well, strength in and itself is an emergent property of this open system, which is the athlete, that is going to have to emerge in various environments in the field of whatever it is that they're doing. So we can't focus our training specifically on lifts or closed skills and expect that to transfer over. So and I think this gets confused in a lot of training, because a lot of people make the assumption that if we get better at lifting, that should somehow transfer over into open dynamic skills, and it doesn't. So one of the things that we've really tried to do in the internal model is learn how to constrain the system to acquire specific things that should ultimately lead to improved skill in open environments. So what we try to do is we try to constrain the training to specifically acquire tissue-specific capacities, joint-specific capacities, qualities of strength that should emerge. And then you have to allow the system to be unconstrained to learn how to use that in skill-based environments. And again, that speaks a little bit to that volume issue as well, because when you consider that you have to constrain training in specific ways to then allow that to emerge in the performance of skills or athletics, you can't spend all of your volume over on one side or the training side. You have to understand that training has to be really, really specific, and you want to try to acquire what you need to acquire in the fastest amount of time possible so that you can learn how to use it over in your skill-based environment. And I think that's one of the things that that John mentioned that I think is important to touch on with respect to the internal model. Now, specifically for the FRA, I don't remember exactly what you asked me, but the FRA tells us where we want strength to emerge per se. So when we use the FRA, we obviously, for most people that understand the FRA, we have certain measurements or outcome measures that we look at within the FRA. And I think one of the things that the FRA does for us is it gives us a good indication of where somebody can move and where somebody can't move. And getting back to another thing that John said in one of his lectures, he talked a little bit about hidden potential. So the FRA kind of right off the bat gives us an idea of where that hidden potential might lie, where somebody can move well and where somebody can't move well. And that gives us that baseline of that understanding. To take that a step further, we can take that FRA or those findings on the FRA, and we can map those findings onto what this person requires from movement demand specifics. So in our language that says that we can take somebody's known workspace, how well they can explore external space, and we can apply that to what their specific demands might be within that workspace. So what the FRA tells us first and foremost is, do they have the necessary workspace for those demands, which is an area of hidden potential that we might have to go acquire through specific training using the internal model. And then on top of that, if the second part of that is when we map their external demands onto their workspace, we can specifically then understand what qualities they might need within that workspace, which we can also acquire through the internal model, whether that be certain types of strength, whether that be a rate of force development or explosiveness, whether that might be a little bit more control per se of that workspace, where we have to focus a little bit more on slow twitch capacity. So that's where the FRA really fits into the internal model, in my opinion.
So the FRA, just for people who don't know, stands for Functional Range Assessment. And just to unpack what you were saying there for people who might not be familiar, the FRA, the Functional Range Assessment that we do, maps the abilities or capacities of each individual joints in and of themselves. So it compares them to what the joint should be doing. And then when taken over time, allows us to see how training is affecting that person. And like Mike said, when you overlay a person's external demands over this FRA, it allows us to very quickly see what it is that they need in order to do that something. So I think that really emphasizes the difference between this internal model and the external model, where the external model is focused on achieving a particular goal or feat of strength in the external environment. we've changed the lens of the focus of training, as well as assessment, at the person themselves. And instead of asking, what do you want to do, and let's break it down and make you do it, we say, what do you want or need to do, and do you have the capacities that you need with which to do that properly, right? And I think we did that to a certain extent with functional range conditioning, and up to this point, we've been getting more and more specific. So let's think in terms of real life now. Where does this make changes for the programming, or for someone training for an individual sport? So for example, let's take a jiu-jitsu practitioner, Dewey, and talk a little bit about the difference between skill work, the difference between training, and what is it that we actually want to acquire with the training internally that would not have been available to us with the standard model training? Or in other words, how does it change what people do, what people emphasize, where people put their energies towards?
First and foremost, the biggest thing it changes is it really shaves down their training volume, at least from a strength training perspective. Because what most people are doing in all sports, but I'm talking specifically about jiu-jitsu, is they're mimicking, like what we just said, they're mimicking what powerlifters and bodybuilders do, forgetting that that's actually their sport also. So now they're doing a tremendous volume of their skill work being Brazilian Jiu-Jitsu, which is incredibly rough, which has elements of conditioning, strength, power inserted into their sport. Now they start to just wreck their body because they're mimicking this standard model training based off of Olympic lifters, powerlifters, bodybuilders. So the first thing we do that usually my fighters are surprised of is we shave down their strength training volume significantly. So now our sessions become something like a 30-minute max, because we now start the session with intent in mind. So I have a target in mind. I reverse engineer the training session to go after that specific intent. So since we're talking about jiu-jitsu, a big feature in this that I always talk about is the ability to squeeze and training the squeeze. So those of you who don't know what I mean by the squeeze, in jiu-jitsu, it's a grappling martial art, and we are always trying to wrap our arms around someone's neck or our legs around their body or neck and create something like a submission or a sweep, or even battling submissions from the defensive end. And that requires a lot of this closing angle strength and the ability to squeeze, of which a standard model doesn't specifically tell us that's what we need. What it's telling us is I need to get better at a squat. I need to get better at a deadlift. So we start the session with intent in mind. We got a good target, reverse engineer the session, prime the body and the workspace to get to that intent so we can actually get after that anatomy that we want to insult, stress, and adapt. So it shaves down our training time tremendously. The FRA is essentially tells us what we need. I always tell athletes, clients, the FRA is going to tell us exactly what we need, and then our training gives you what you want. So we don't assess movements, we assess joint capacities. And then the question we want to ask is, from that assessment, does your anatomy and your biology match the goal at hand? Yes or no? That's the first step. So do you have enough workspace? Do you have enough capsular space to achieve what the goal is? So if it's jiu-jitsu, do I have enough workspace to battle through a Kimura submission and buy myself time to escape that and hopefully not get injured because I have load-bearing capacity in my connective tissue? Now I'm buying myself more seconds because I have more workspace to travel through. I can maybe escape that. Now, on top of all of this, shaving down all that volume, the biggest thing that does in my mind is makes their body healthier also, because we have intent, we go after that goal. We don't start layering on more unnecessary volume and breaking the biology and physiology down, really unnecessary to do that.
I have several questions, and there's a lot of stuff there too. So one thing quickly I wanted to say is I do want to point out that you talked about this idea of Kimura strength, and we talked earlier about this idea that there's no such thing as generic strength. We touched on this a little bit. Strength it's not a something. Strength is a behavior. It's when you harness all of the components or determinants of strength into this one focused application of force. And a thing that you pointed out is, that application of force, to do that from here, it's not the same as to do it from here. In other words, the anatomy that's being stressed in this position is not even close to the same anatomy that's being stressed in this position. So the concept that I can become generically strong doing this, people almost think that you achieve strength by getting strong at, let's say, bench pressing. So I get strong doing this, therefore I am strong. But to get strong doing this comes with certain anatomical adaptations and changes that make you strong at doing this. One of the things that would not be stressed in any training doing this would be, for example, the end range of the articular capsule, which is exactly what's being stressed if I'm being locked into a Kimura. So the idea that strength somehow improves all of the anatomy in a way that all of the anatomy gets to benefit from this strength-induced pushing that you've been training, it's just a failure to understand what the training's doing. The training is supposed to be to alter your anatomy for a specific thing. That's why the specificity principle exists. So I think that's a really important thing to point out, is that training comes with anatomical consequences, good or bad. And just because you stress certain, it's like saying, if I get strong at gripping with my right hand, my left foot will also get stronger because I'm stronger in general. It sounds crazy to say it that way, but it's the exact same thing. The idea that you think that an explosive snatch is going to get you out of that Kimura is a failure to succumb to the mountains of research that make up the specificity principle. But
yeah, again, it's starting with that false target, right?
Exactly.
If the target is to get better at a demonstration of an exercise, we have a false target. Therefore, our training certainly cannot be as specific as it needs to be. And we end up doing a lot of unnecessary things.
Now, getting back to this, we've been talking a lot about the volume problem, and we know what that means, but let's break that down a little bit because it's such an important concept. So generally, as we say, that you have a neutral zone for a lot of capacities in your body, being the zone that your body is used to. And then we talk a lot in the seminars about, if you want to push change in the body, you have to bring yourself into a stimulating zone of work that is something different than what you maintain as neutral. So we have these neutral zones, and then we have these stimulating inputs, and then we have, efforts that are below your neutral zone, right? Which we use for for other things as well. So when we discuss the volume problem, what we're saying is that people tend to spend all of their time in that neutral zone. And what it gets confusing is that with athletes, their neutral zone is large because they do athletics at, let's say, a high intensity, right? And then, they also have rest. But just because they're working at that high intensity, they're used to those intensities for the skills that they output. So I always give the example when we're lecturing that when we were dealing with we had a seminar with a group of MLB teams, and we had all of the coaches in the room. And when we started, we looked outside, and I remember before we started lecturing, there was players in the batting cages, right? So I'm sitting there and I'm lecturing. So an hour goes by, and I just happened to look up again, and I see that the same players are still in there, and they're at the batting cage. And then after that, when I noticed them come into the gym area after they were done with that batting practice, they started to train, strength train, because that was skill work, and now this is their strength training time. And they proceeded to do a whole bunch of rotational based exercises, and they did them at stimulating inputs they're no higher than what they were just doing for that past hour. So the question that I kept asking is, if your body just went through an hour of rotational exercise whereby you're hitting a projectile object at the end of a long bat, so a long moment arm, that's a lot of rotational force and a lot of rotational work. Now you come into the gym and you say, I know what we need to do. We need to work rotation. But then you have to ask yourself, well, what were they doing out there? It's almost like people uncouple skill work and how that affects your body as being something separate from how training affects your body. So now we get to this volume problem. They just did an hour of volume work in their neutral zone. And now they came into the gym and now they're doing rotational exercises also within their neutral zone. So somebody jump in and speak to that as we define as this volume problem, and what is the problem? Somebody tell me, what is the problem with that kind of mentality? Quint, I'll go to you.
Okay, yeah. So so can I say something before I get to this question?
Absolutely.
Because you guys were discussing the specificity principle, biological law of specificity, or specific adaptations to impose demands. Okay, and there's a lot of theory on how that works, but we have practice to show how that works. And let me explain that. So you guys were using an example of a jiu-jitsu athlete in right, and how the adaptations, structural adaptations of a bench press won't convert over to that. Okay, now here's what we know, and I know this based off of not just like my work, but everyone's work that runs the FRA. When you ask them this question, and let's say that you get, since we're talking about powerlifting too, you got a powerlifting athlete, because I treat a lot of guys at Westside Barbell, a lot of athletes, both male and female. Here's what's interesting. Let's say that you're going to run, hey, I'm going to run this 3-week wave with 1-week deload on a bench press. I'm going to try to increase maximal absolute strength. You go, okay, that's great. So we run an FRA on the shoulder joints. Okay, because this is what I do. Run an FRA on the shoulder joints. What are you going to see happen? Okay, you're going to see bench press goes up. So you ask the lifter, hey, did your bench press go up? Yes, it went up. Then what you're going to see on the back end of the FRA is, guess what? Fundamental shoulder joint function has went down, which is exactly what you guys are describing, which is the law of specificity in practice, where you can see it live. But one of the reasons why you can see that live is because the specificity of training at Westside is so high that you know exactly what they're training to acquire. And you can see how, as they acquire that absolute strength, what happens internal system. It pulls from that internal system, which obviously then this is how we know that you have to be running. So think about it this way. I mean, it's not hard to understand that, listen, as your absolute strength goes up, meaning you're handling heavier and heavier loads, but your shoulder joint, the fundamental thing your shoulder joint does is decreasing. Okay, that is not a good scenario to be in. And unfortunately, that's the scenario prior to running the FRA and having that feedback mechanism that we know that we didn't know about. So then we go, okay, well, hey, if you have this phase, or you're gonna run to acquire this very specific strength adaptation, then you have to run the internal strength in parallel with it, so that you're at least not losing that fundamental joint motion. But yeah, what we did in the model is we took how, the belief is the training intensity. If you look at really any of the literature, the belief is that training intensity is what's going to push the adaptation of strength training. So the whole goal is to really constrain training intensity. If you can constrain and control training intensity, then in theory, you can really control the training adaptation that you want. That's what the 4 methods of strength training in the external system that the Soviets did. That's what Westside does. When you start to figure out how to program those over time, and you're running multiple things at once, that's when you're actually running the conjugate sequence system, right? But what I think everybody's kind of discussed it. Like, think about it this way. What we did was we said, okay, well, according to the literature of strength training, they say that there's 3 intensities. You got your stimulating intensity, you got your retraining zone, and you got your detraining zone. So let's do what we've been doing this entire time, and let's actually view the powerlifter or the Olympic weightlifter as an athlete, and that is their skill. Okay, what you will see is when you go to do your maximal effort work, which is the superior method for building absolute strength, according to all of the literature, then you can see that will be at a stimulating zone. But now let's go to, hey, let's build a quality. Okay, well, what is that quality? Let's try to increase the velocity of that. We're actually moving down from a loading perspective into a retraining zone. Why? Because they're learning to use the skill of how do you move the barbell? How do you exhibit force? You know, that's why the force posture curve exists. How do you display force? How do you utilize this ability to generate this magnitude of force and display it into a bar? And so because that's kind of missed, people see the volume that a weightlifter does and they go, well, I need to do the same volume. And we go with a model, we go, no, you don't have to do the same volume. You can see that they're trying to acquire these very specific things, and these are their stimulating inputs. So what you have to do is you have to figure out what exactly you need on the internal level, and you have to have the intensity at those stimulating levels. Then you also have to have the intensity at the detraining levels, but we're staying out of the zone. Really, the only time we go into the retraining zone is when we're trying to do stuff for controlled articular rotations. Think about it. You run expand capsular space, which would be like input cycle 1, right? Which majority of people are going to know. Think about it. That's a stimulating intensity. So from a programming perspective, what you could do on the back end is then you could program the controlled articular rotation in a retraining intensity, because you acquired access to more space. So now retraining the nervous system, just like a lifter would train their lift. So I think that that's the main issue with the volume problem, is people are not actually respecting, or I don't even know the nomenclature used, but they're not looking at a powerlifter like an athlete or a Olympic weightlifter like an athlete. And then they just say, well, this is what they did to get strong. But they forget the entire skill of being able to actually beat. That's why a lot of times when you listen to a powerlifter say, this is how you're going to bench press, right? Because, you know, my background's in bodybuilding. And when I got invited to West Side, it's like how the powerlifters there bench press was completely different than how I bench press. Because I bench press to try to acquire, you know, muscular hypertrophy. I wasn't trying to move the largest amount of weight. That obviously becomes a skill.
I think, let me stop you there, because you're getting into the concept of accommodation, which I think will also work well for this conversation, is that when you're doing traditional strength training lifts, when you're getting better, you're trying to get better at that lift. And when you're trying to get better at that lift, the context or the intent of your training is now in the external environment, i.e., you're trying to get better at the display that is that lift. And what we're saying is that the more you focus on the display of movement, the more you hone the internal system to produce that particular movement. But when you go back to Dr. Chivers was talking earlier about the dynamics of sport, it doesn't always translate, because like we said, being strong isn't just a generic thing. So getting back to this concept of accommodation, one of the big things about the internal versus external model is that we're saying that the majority of your efforts should be honed on trying to make changes within the biological system that will allow the nervous system to output the capacities that you need in the external environment, right? So if you shift the focus of your work from this external into the internal realm, and instead of saying, you know, what are we doing today? Well, today we're working on making my bench press better. What we're saying is, well, today maybe you should be working on your particular problem of shoulder internal rotation, which is hindering the general capacity of your shoulder, which is utilized to perform a bench press. So if you hone or if you focus your training inside and start to ping off these specific determinants that will allow you to assemble these movements in the external environment, what you end up doing is you end up warding off accommodation. And I think that's very important to note, is that, you know, arguably what strength science is the science of warding off accommodation, meaning that you want the training inputs to actually do something. But the better you get at something, the more trickery, so to speak, your nervous system uses in order to achieve that goal, such that it tries to achieve the goal using less energy. And really using training to create adaptation is the utilization of energy. And when you start using less energy to get the same results, the body stops changing. So one of the great things about the internal system is when you focus the majority of your work on the internal environment, you consistently bring a new athlete to the lift or to the exercise that you want them to get better at. And when you bring a new athlete each time to that lift continues to, you continue to reap the benefits of that adaptation.
Yeah, because like what John was saying about absolute strength going up on something like a bench press and fundamental joint function goes down, like that's not a good thing, because that's saying I have less access to myself. I have less access to my biology. So I cannot solve as many movement riddles as I could if I had better fundamental joint motion. And really, we wouldn't know that if we weren't doing an FRA. If we were just, again, assessing whatever the movement is, it's not going to give us that answer. We're just looking at getting better at the lift.
So
more specificity to a lift equals more accommodation, essentially.
Mm-hmm.
I think is a simple way to put it, right? And so if we understand that if we're trying to achieve more specificity on a lift, you are going to accommodate more in direct correlation or direct relation to the specificity you are applying to the lift.
So really, we're not pulling away from, if somebody does want to get better at deadlifting, if that is their thing, where the internal model does not somehow negate your desire to get better at deadlifting. If anything, it's going to make that process a lot more efficient, because you're going to constantly improve the capacities of the tissues that actually produce the force needed for that particular deadlift. I guess, sorry, go ahead.
No, one thing that I wanted to say when both you guys were talking about bringing a new athlete, it's a new athlete, but caveat to the athlete, it's a trainable athlete.
A more trainable athlete.
Right, so the athlete isn't just new. That is correct nomenclature, but incomplete, because the athlete is now more trainable. They can absorb more of the training that you're putting in.
Mm-hmm. That's
right?
a good point. People tend to forget that the learning mechanism of the motor system is dependent on the health and functionality of the tools you use to move with, which are your articulations. Meaning that spending time making a joint healthier is ultimately, in the end, going to improve your skill acquisition on the back end of that anyway.
Yeah, and let's think of it this way. Were you going to say something, Shivers?
No, I was just said, yeah, of course. Go ahead though. I'll go after.
Yeah. So think of it this way. You look at what it was one of the biggest processes that in the process to obtaining sports mastery for Soviets, selecting the right athlete, right? Well, think about it. It's the same thing. That's from the external perspective, but if we look at it from the internal perspective, like you have to have trainable, like just like you have to have trainable athletes, you have to have trainable joints. And I remember Chivers told me this, and it made sense. And it's like there's a whole. I shouldn't give him credit now,
Yeah.
but there's a whole internal level that people aren't even aware of, right? So when we're discussing, for instance, we're talking about specificity of training effects, right? So if people want to know how that works in real life, you look at the science and practice of strength training. Look at what happened to Soviet shot putters when they ran only maximal effort. What happened? At some point in time, they accommodated and weren't able to. They lost speed strength characteristics, and the shot put them down. So they knew that only. Okay, so think about it, and everybody's accepted that. Everyone's accepted that the force velocity curve. Hey, you got to train. You got to train for absolute strength, but you got to train for speed strength qualities. What people, I think, what the internal model, what the whole entire system is going to show people is it's like, listen, there's a whole internal level that you guys don't know about of these other relationships that exist, i.e. maximal strength goes up in a bench press, but guess what? That's external strength training with the intent to just improve how much load you can move through a very specific external zone. Well, what is the trade-off for? Well, there has to be a trade-off in biology. The trade-off is going to be at the joint level. right? It's going to be at multiple levels, but we're just using something that we can actually assess objectively and all agree upon. So just like there's an inverse relationship between force and velocity, there has to be an inverse relationship between acquiring external training effects, i.e. I'm getting better at this feat of strength, this sport, and then obviously back-end effects off losing fundamental joint function, capsular space, et cetera.
Mm. So, and I guess what you're also pointing out is the accommodation that we've been discussing. The accommodation, contrary to popular belief, doesn't occur at the external level. You see the results of accommodation at the external level in that, you know, the shot put goes down, but all of the accommodation was happening internally. And it was happening because the body was getting used to using the biology that they have in more dynamic ways so as to cheat the movement, so as to use less energy. And that brings us to that concept again, is that, you know, swimming, for example, is a great exercise when you don't know how to swim. But the better you get at swimming, the less exercise you get because your body learns to accommodate. But that accommodation happens internally, which once again points to the importance of cultivating a new internal environment so as to make your external training methods actually mean something internally, and to make it so that adaptation can in fact continue. Another important thing, I guess, that you had talked about is the specificity of training, but more specifically, and I'll put this question towards Mike, with regards to the specificity of training, I think that in the standard model of training, the specificity of training was really focused on one particular type of anatomy, what we call the red tissue, the muscular tissue. Even in the nomenclature of exercises, it's like I'm doing the, you know, delt raise, or I'm doing a bicep curl. There's an inherent focus on this muscular tissue, but as we've uncovered through, you know, I don't know how many years of literature up to this point, but more recently, if you look at the literature on strength training, you realize that you can break up the ecologies of the body of the person into sub-ecologies, each of which is in fact trainable.
It's funny that you went here, because as we were discussing this was the segue into this discussion, right?
Yeah, you know what? So maybe take over, because I think one of the things that we talk about at the strength course, and you know, people, their eyes light up there, is that there's enough literature to support the training of very specific tissue ecologies in the body, as opposed to just considering it from a muscular perspective. So maybe I'll leave it there and let you take off.
Yeah, I mean, this is it's a big topic, so I'm not really sure how to pull it all in. So, you know, anybody can jump in as we go. But I think, like if you read, I was just doing some research on plyometric training. So like reactive strength. So there's some qualities that are necessary for reactive strength. What are those qualities that are necessary for reactive strength? Well, we need muscular strength, obviously, some relative muscular strength. So what is reactive strength? Reactive strength is just your ability to explode off the ground with stiffness, right? So they measure it. This is not important for this discussion, but it leads into this discussion. They measure it by like how high you can jump in like a stiff ankle hop, divided by the time spent on the ground. And that gives you like a measure of reactive explosiveness. Make sense? So if you actually look at some of the literature that we have on reactive strength, generally what they'll say is that reactive strength requires some strength of your lower limb, obviously. It requires some stiffness of your tendons, your Achilles tendon specifically. It requires some stiffness of your foot. It requires some range of motion in particular ways of your ankle. And the assumption is that, well, I can do general exercises that focus on those areas, i.e. calf raises. I'm making this really simple. And by doing calf raises at various loads, or weights, I will acquire that muscular strength and that Achilles tendon stiffness and that ankle range of motion that then will allow me to get reactive strength. But that doesn't make any sense, right? So I think what I'm trying to get at here is that if you look at the prerequisites of reactive strength, ankle range of motion, that is a trainable quality that comes with a certain ecology that is associated with ankle range of motion. That would be accessibility to more capsular input, or capsular space, as we would call it. Achilles tendon stiffness, well, that's what we would call white tissue. That's tissue that has certain behaviors, and those behaviors are different than muscular tissues. And because those behaviors are different than muscular tissues, connective tissues should display certain elements or have certain behaviors within dynamic movement that should be trainable. That's a different ecology, right? And then you would have what we would call red tissue, which just relates to muscle, that also has specific behaviors. And those specific behaviors are dependent upon how much load is being moved or how quickly the movement happens. And those are trainable qualities. So in the internal model, we've said, okay, well, there are different ecologies that make up this grand thing that we call strength. And strength is different for different things, and it has different emergences in different environments. So we can take all of the anatomy, what we would call the biological elements, and we can divide them up and say, well, they all have these interrelationships and they all create feedbacks to one another, but they're all different. They all are made up potentially of different tissues, and therefore they have different behaviors and they have different qualities. And each one of those behaviors and each one of those qualities is trainable in the model. And so we can break those things up and say, okay, well, we can focus specifically on connective tissue as a trainable element. We can focus on muscle tissue as a trainable element. We can focus on the joint, which most people wouldn't think is trainable, as a trainable element. And then if we can do that, we can say, well, each one of those as well is going to have a certain capacity. And there's a certain capacity right now at a certain point in time. And we can then make that capacity as dynamic based on how we train and how we move in particular sports. And so getting back to an assessment can give us indications of what that capacity is. And so we can start to push individual capacities and specific tissues, therefore training specific ecological niches within this grand ecology that we call the human system. And the goal would be that if I increase specific ecology of connective tissue, that would create feedbacks and carryover and interrelationships into joint specific ecologies or muscle specific ecologies. And the more I can take and divide each one of those things and understand the capacity of each one of those things specific to demands, I can then understand at what point those specific ecologies are, and I can understand how to push the adaptation of each one of those to create, as John would say, cumulative multifaceted effects, so that I can then gain what I wanted to, or acquire what I wanted to acquire. So getting back to my original example, when you look at this concept of reactive strength, coming from just these general qualities of, well, doing lower leg exercises is going to give you all of those. Well, we can now say, well, reactive strength is an output. It's a capacity of these different ecologies. And if I want to improve my ability to have reactive strength, I must understand where each one of these ecologies is right now, so that I know where to push, whether that be creating more connective tissue architecture and stiffness, which we have in the internal model, whether that be creating more accessibility to muscle tissue so that it can pull on that connective tissue with more force and create more explosive outputs. Or is it just that I don't have enough ankle capsular space to actually create that explosiveness off the ground? So I can understand which ecology can be pushed to try to create this accumulation that will eventually lead into what we would call reactive strength.
If we bring this, closer to home in terms of how this changes your training, let's give an example. So you have an athlete who has a history of chronic low back pain. Okay. Now, to us and to people who run this model, you immediately think to yourself, well, there's anatomical consequences to a person who has chronic bouts of low back pain. For example, we know from the literature that one of the main consequences from having any bouts of low back pain is the beginning of atrophy or loss of slow twitch fiber capability in your multifidi. Okay, so here's an example. Now, you take that athlete and, in the standard model, you do your history and it might come out that they have low back pain. And then you might, when do you have low back pain? Last bout was whatever. And you look at their deadlift is going up. So the assumption is that you can just continue to get stronger, because there's a general assumption nowadays in social media and whatnot that strength is great no matter what. It's just get stronger. Who cares? You can never go wrong with strength. What it is, but the idea, for example, that if you take a person with that history versus someone who does not have a history of chronic low back pain, and you get them both to deadlift, the idea that deadlift means the same to body A and to body B is to disregard any and all literature that's ever been done on the concept of specificity. And therein lies a difference between an internal model versus an external model. In the external model, deadlifting is a very important thing that you just cannot stop doing, because, oh my God, how are you possibly going to, stimulate testosterone release and the endocrine system and et cetera, et cetera. But if you understand training as not a collection of exercises, but as the management of force inputs directed at specific targets to achieve very specific outcomes, then you realize is that you can put your energies in a variety of different places. It doesn't have to be in the deadlift per se. Maybe your energies can be spent on reestablishing slow twitch fiber activation of the multifidi. And maybe that's where the next training block, the next 4 to 6 weeks, needs to be inputted. So I'll give another example, and maybe you can go off of this. Take someone who had a history of an ACL rupture that was replaced by a semitendinosis. Now, from an external perspective, you might say, okay, well, make that hamstring strong. But can someone speak to the idea that, what do you mean by strong? Like, if you took a hamstring graft in order to replace your ACL, and now let's think about the hamstring, there's anatomical consequences to that graft being taken. And standard model training to just get strong doesn't consider those anatomical consequences. So how does the internal model change in the programming of that particular individual?
Okay, so again, this is a pretty open-ended one. But specifically, getting back to how I was describing that before, you would say, okay, well, instead of saying, the hamstring, because there's a graft there, let me start this again. If you look in the literature, based on this type of procedure, what are you going to see? You're going to see, and this makes a lot of sense, and I know specifically this relates to you. If you have a hamstring graft for an ACL reconstruction, you are going to live with hamstring weakness, according to the literature. Well, when I did my ACL, I had a bone patellar bone graft. So what am I supposed to live with? I'm supposed to live with quadricep weakness. And I think that is a consequence of not thinking in anatomical terms. And I think that's a consequence of not thinking of these different ecologies as we spoke about before. So traditionally what you would see then is you would see, your normal ACL progression from a rehab perspective. And in hamstring cases, there might be a little bit more hamstrings focused exercises. And when I say hamstring focus, I mean hamstring as a group, just doing more hamstring stuff. And in my case, I remember in my rehabilitation, there was more quadricep focused stuff to try to strengthen my quad to try to get rid of that long-term weakness. But again, it's too broad. So what we can now say is we can say, well, there's different ecologies that exist here. And the hamstring is made up of some tendinous material that is white and some intramuscular material that is white. And where the graft is taken is all white. And where the bone-patellar bone graft is taken is all white. So if I understand that, then I can specifically target that particular ecology to try to build that ecology from the initial starting point to the point where you're getting into more dynamic type rehabilitation. So what would that be? Well, we know that the first consequence of connective tissue as a graft would be guiding the way that it's healing and the way that these tissues are aligning and so on and so forth, which we would call architecture. So that would be applying specific inputs, training and otherwise, that would target the architectural properties of connective tissue, because connective tissue behavior is built on a specific organization. So if I can guide that through the initial process of healing, then I'm preparing that tissue to then behave as it's normally supposed to behave further on down the line in time. Going from there, you can move into increasing the load-bearing capacity. So again, getting back to what the literature would tell us, would say hamstring weakness, quadricep weakness. Well, that's not because the quadricep or the hamstring is not strong per se. It's maybe because it doesn't have enough white stuff to pull against, because it hasn't necessarily been a focus of the training process post reconstruction. So then I can take that architecture and I can apply different stimulating loads that would create stiffness and otherwise load-bearing capacity of that tissue as a prerequisite for then training the hamstring or the quadricep, depending upon graft, for certain qualities of strength, depending upon what the demands of that knee might be further on down the line, so that now the red tissue, otherwise the muscle tissue, a different ecology, has the ability to use the connective tissue to generate whatever force outputs it needs, depending upon, as I said, the specific demands of that knee further on down the line. Again, traditionally in the rehabilitation model, we would say that all of those qualities would come from just the progression of exercise. But again, what we're saying is that it's not really the progression of exercise that focuses on the specific resources that the system has to build upon. It's specifically focusing on each biological element, each ecology, to then create these multiple relationships that they can all work within and create, so that ultimately you can have larger global behavior sometime down the road.
You bring up good points there about the production of strength, which may not be taken into consideration in the standard model either, is that, there's really, it's becoming strong, as we said earlier, is not one thing. So we talked about red tissue. There is a way to become strong by improving the capacity of your red tissue to, generate force. But where that force pulls against, where that force has to flow through, is another determining feature as to whether or not, you're making use of the force you generate. In other words, if you have force generation put through connective tissue that can't absorb that force, then you have a loss of force generation. So, there's, the generator of the force, there's also the purveyor of the force, both of which need to be strong. However, again, going back to the regular model of just get strong, it's almost like the assumption is made that when you choose an external exercise, that the exercise somehow knows what you need automatically. So if we bring this back to the lumbar spine, a lack of slow twitch capability in the multifidi, and then you have this other client who presumably does not have that problem, and then you tell them both to deadlift. Well, the fact that we have different mouth noises for slow twitch fibers versus fast twitch fibers inherently means that there's a physiological difference between them. So when you go to a deadlift and you grab it and you go, "Huh!" well, you're really contracting as fast as you possibly can, which means you're likely not going to stimulate change in the slow twitch fiber in that particular person who needs it. So there's an assumption that strength somehow covers up all anatomical problems, when in reality, strength is derived from the anatomy that you're pretending hasn't changed, if that makes sense. So I guess
that's the behavior that I was trying to reference, right? Like, and I think you said it earlier in this discussion, is that strength is not a thing. Strength is a behavior that can be demonstrated at a particular point in time. And that demonstration in a particular point in time is strength of different things working together and creating this feedback that allows for what we would observe as the demonstration of strength, right? So like the ability to do a maximum effort deadlift is a different type of strength than, watching a football running back run at full speed and then change direction in like the blink of an eye to get around a defender. That's also strength. It's just a different demonstration of strength. And both of those demonstrations of strength are the culmination of these different feedbacks amongst the system to generate that output at that specific point in time. And so when you put it in that way, it's impossible not to look at strength as being a behavior that can be trained specifically in specific tissues that are going to then, create this particular strength-based output.
That is the stagnation. We agree. That is what we consider to be the stagnation of the standard model of training. Is the stagnation lies in the fact that we haven't considered all of the physiological evidence that has been given to us through, thousands and thousands of researchers, in that we still come at it at a very generic way. So let's bring this back to something that Quint was saying. There's, if I say, what are the 4 ways that you can strength train? I think you mentioned the different types of ways, right? So mention them again, just for our people. So there's 4 ways to do it. They are.
Yeah, so the 4 ways is your maximal effort method, and that's going to increase absolute strength. That requires using a load about 90% of what your 1 rep max is or above. That's going to increase maximal force output voluntarily. Then what happens is force, that's going to increase the magnitude of force one can generate. Then you have dynamic effort, which is going to increase how that it won't increase the magnitude of force, but how fast that force gets discharged. Okay, because we understand the force velocity curve has an inverse relationship. Then after that, the only things that's left is repeated efforts, and it's specifically repeated efforts to failure. What that does is it takes the muscle tissue to physiological failure. Once that failure occurs, what happens is it sends a signal to the body that, hey, we need more force producing tissue here. Thus, you start to get hypertrophy-like effects. And then the only other thing that you can do is repeated efforts not to failure, which would induce and think about this, because you'll see people train, do repeated efforts not to failure, but elicit hypertrophy. What does that tell you? They're untrained. That's why those studies don't. And the only other thing that I'll add, because I know you're going to get this, is talk to this, but the force velocity curve is constrained by the connective tissue, which is a very important thing that's missing in all the literature. is essentially this force velocity curve is constrained by the connective tissue architecture, and nobody's really discussing training of connective tissue realistic to this model. But yeah, that's the force.
So I think let's point it out. So in the internal strength model, we're not changing these 4 models of how to train. There is no way to change that. Those 4 ways from now until the end of strength training will be the only 4 ways that you have to select from. But what we're doing in the internal models, instead of saying, let's apply these 4 ways for the acquisition of some external feat of strength, let's turn these lenses inward on the body and use each one not to cultivate generic strength, as Dr. Chivers was talking about, but to use each one at very specific ecological targets, whether that be I'm targeting the joints' available ranges of motion as being a trainable quality, versus I'm targeting the connective tissue stiffness that is required for, let's say, plyometrics, that is a specific tissue ecology, versus if I'm training muscle, am I training muscle for fast twitch purposes, or am I training it for slow twitch purposes, versus am I training it to add more anatomy versus to, build on the efficiency of the anatomy that's there. I think that the major concept here is where all models of strength training, we believe, at least, left off. If we go right from the Soviets right into West Side, they left off at this point where all that they were doing was obviously working to make people stronger, but the idea of cultivating the person themselves, that's where the stagnation occurred. And I think that's where we're taking the reins here and saying that if you change the lens from the external perspective and you hone it inward, and then you pull in all of the recent literature on mechanotransduction and the importance of connective tissue stiffness and et cetera, as we've been discussing, you realize that the specificity of your training can be enhanced tenfold, because now you're specifically training to acquire tissue-specific capacities, which will then help you with the amalgamation of training in the external environment.
And this problem's it's not only a problem in strength training, but also like rehab, what Mike was talking about, the ACL example is, basically the rehab is to get more hamstring strength or quadricep strength, which is red stuff. And it was an injury to the white stuff, and now we're just ignoring that. Well, if we ignore that, the load bearing capacity, the architecture of the white stuff, what should we expect? What's the most common injury you get after an injury you got? Probably the same injury, if we're just looking at increasing strength of red stuff. So again, a false target.
Now that you came in for that, Dewey, if we speak about this in the concept of endurance training, we realize that doesn't, there's no difference. And I think the way that we view endurance training is much in the same way, whereby, when you're doing endurance, people, I think, often forget that their endurance is a production of some anatomical structure in the body. In this case, your endurance is a production of your heart to a certain extent. And the heart itself is another trainable quality. In other words, you train your bicep, you want your bicep to be bigger, or you want your bicep to be smaller, or you want more fast twitch, or you want more slow twitch. We kind of understand that is an option for us in training, but we don't really apply the same concept to endurance training, and specifically the structure of the heart. And the person that just came off the street who might be overweight and whose diet is mostly fast food and they haven't trained before, that person has changes in their heart that also need to be considered more specifically.
Right. Yeah. And even someone who ignores aerobic conditioning or endurance type training, and maybe they just do a lot of strength training, or maybe with their strength training, they just do a little bit of interval training, high intensity interval training. Well, yeah, they're going to get a lot of development of the outer wall of that heart, which is going to make it beat faster. But if they have a dinky little pathetic cavity, well, that's a problem for a lot of reasons, but they also have no endurance, whether that be for a strength and power sport or an endurance sport. But there are different adaptations depending on the stimulus for conditioning. Not to mention, there's also kind of general global conditioning, sort of talking about the heart, and there's specificity to the heart. There's development of the outer wall, there's development of the cavity, enlarging of the cavity. But there's also localized tissue endurance and conditioning. So like you want to make a high level endurance runner stronger, well, you can decide to add mass and slow twitch fibers specifically in a localized region of their body. Do they need more hamstring stuff? Do they need more ankle stuff? Do they need more intrinsic foot strength? Those would be powerful things for those type of athletes. So there's localized conditioning and there's global conditioning, talking about the heart or talking about specifically about localized tissue adaptation.
That's a great point. I mean, I'm conscious of the time, so I don't want to take too much more of it, but that last point you said, it's a great one, because, you know, if you have the greatest, you know, endurance athlete comes into your office and says, I need to be greater, it would seem to me that the conclusion should be, if they're the best, they probably squeezed as much endurance as they can out of the anatomy that they're working with. So what do you do with this person? Well, in the standard model, you do more of the same. You do more volume. You do, well, let's push your endurance even higher. But your endurance is a result of anatomical output. So at a certain point, you can only get so much endurance out of your anatomy. And then the question becomes, well, now what do I do? Like we've been saying, you change the anatomy. And not only do you change the anatomy by making it strong, you change it by making it specifically strong in the exact way that would help them generate more endurance, which, like you said, would be localized slow twitch fiber training to failure, which is something that I don't see anywhere in the standard model. But one more thing.
Let me jump in there for a sec.
Yeah, sure, go ahead.
I think it behooves us to mention there as well. So when we say, well, you would add more anatomy into that. What we mean there in a little bit more detail is we would understand that, and this goes with any athlete, but particularly because we're on running, that running is going to ingrain certain patterns of movement in that athlete, particularly people who are doing it at high levels, so the elite levels. And so as a result, when you put them through the FRA, there's going to be discrepancies, right? Because they're going to be patterned to be runners. So how do you make a runner potentially better is you give them the hidden potential of just movement quality first, because that's what the FRA is going to tell you, right? And then you can understand where anatomically they might need more. But when we say that we would add anatomy or we would change the anatomy somehow, we're talking specifically about adding more of it or adding a specific behavior to it. And that's what the internal model does. The internal model doesn't just necessarily, and I know we all know this, I just want to make this sort of a detail. We're not saying that all runners, you're just going to add more stuff to them. What we're saying is that in that initial analysis of that runner, understand that what makes them good at running is also what is going to make them plateau at running. And so we can understand where those plateaus might be specifically from a movement acquisition perspective, where that hidden potential of movement might be. And then when we grab that hidden potential of movement, we're saying, okay, that might lead us to then think we have to add more stuff or add efficiency to that stuff or add more stiffness to that stuff. That is adding specific qualities of strength to that stuff, which will then ultimately lead to more improved performance of that athlete.
I do want to touch on one more thing. I'm assuming this might be part one of a series of podcasts on the same topic, because I'm sure we can go on. But one thing that I do want to touch on is we've said a lot about removing volume from training. And if you give me an athlete, who trains in the standard model, you give me a whiteboard with all of their, 5 exercises for their anterior delt and 7 for their middle delt and 5 for their posterior delt and dead bugs and da 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 da. First of all, I don't know where athletes get this much time to train, considering they actually have to train in their sport. But what we tend to do is we tend to take our eraser and we just eliminate a lot of the volume that is being spent on maintaining these external demands, and we point them inward to try to maintain the internal capacities versus the external demands. So in doing so, we pull out a lot of volume, but what we also do not do is we don't take away from the intensity, because we understand that intensity, not exercise selection, is what drives adaptation. But what I do want, and I think I want Quint to say this specifically, is answer me a few questions. When you're training an athlete, how many different things can you work for at a time? And it's a very important question, because I think in people's brains, when they go to a gym, they go to they look at their workout and they look at all of these exercises, and they somehow think that all of these exercises are simultaneously being adapted in one direction at all times. And I think that might be the reason why when we remove volume, people start to panic and they're like, what am I going to do for the middle head of my tricep? If I don't train it 3 days a week, it's going to go away. Can you speak to the idea of not being greedy and the realistic, what can you realistically intend or hope to push for? How many things at once can you actually improve in an athlete?
Yeah, I'll give an example of, like, let's say West Side Barbell, okay, like an actual real life example. So if you look at a day where they're going to try to increase absolute strength, right? So what does that mean? They're going to use maximal effort method, and they're going to use that in a lift. So let's say a bench press. Okay, that's one thing that they're pushing for. One, right? Then it transitions into, a lot of times, repeated efforts to failure in specific tissues that need to increase in size. And so it's not a lot of volume, right? It seems like it is. A lot of the volume comes on the speed days, right? Because you're using submaximal loads and you can get away with that. So realistically, and this is the thing, I know the question that you asked, right? But it also depends, obviously on their aerobic base, how much conditioning work they're doing, how much stress this can handle, etc. Okay, but how do I word this? Like, this is what I think one of the main issues is. Like, let's look at West Side Barbell one more time. Okay, where are they, at what point in time are they constraining the maximal effort work that they're doing? Never. It's an absolute strength sport. They're training it indefinitely. And we start to pose the question where, when we were talking about specifically the volume, we have to agree that there's a certain amount of external strength someone can have, right? You don't need to, if you're a running back, you don't need to have a 700-pound squat. So at some point in time, right, you have to know when to stop trying to acquire these external things, because if you're using, the system that the Soviets developed, the system side has really refined, you will actually acquire those numbers quite quickly, quite possibly in high school and college, and never have to train that max effort again. So if you're talking about not having to train at max effort, to answer your question, right, or your max effort is now in a retraining category, okay, now you can see it opens up solve the volume issue, because you have this capacity that you need. You have to generate a certain magnitude of force in your lower extremities. You can do it. Once you can do it, start to train other things. And that's what really opens up the availability to start to use the internal model to then start to acquire connective tissue architecture, connective tissue load-bearing capacity, et cetera, right? But realistically, if you're trying to acquire, it's one or two things. The body doesn't have this infinite ability to absorb all of the training.
So really, we're saying that you focus on what are these specific capacities you need. You then take your exercises and focus intensities accordingly to say, I'm driving for this particular thing. That is where I'm going to put the vast majority of my high intensity stimulating work. and then you backfill the program by putting either retraining or detraining work, again, focused on the internal model. So in other words, you're consistently cultivating the internal system, and then you're selecting external exercises based on need and need alone.
Yeah, let's use the exact example that you brought in about the individual that has issues with multifidi. Are we going to have them stop deadlifting? Not if they need to be able to, not if that's something that we deem essential. What we would do is we would put it down into a retraining category, and then we would push the internal model into stimulating stuff. So we're not even removing it. We just know that this person doesn't have a trainable spine. So why are we going to try to build, you know, on a spine that's shitty and dysfunctional? What we're going to do is we'll just be patient with that. We'll take the time because we know how efficient the internal model is. We'll run, hey, maybe 3-4 week wave to really acquire all this stuff. Once that stuff's acquired, then maybe we'll flip-flop it.
I think we should maybe, because of the time, end it there. But if we're going to go into a part 2, I think maybe we should be examining training intensities and specifically energy distributions and how to distribute them specifically to achieve specific tissue capacities, and how that changes the structure of the training. And then another thing I think we should get into next time regarding this internal model is the changes in the workflow, and how with this perspective you can actually change not only what you do in 4 to 6 week cycles, but also on the individual days of training, how turning the microscope internally and looking at how the body sees itself provides a very strong foundation as to how to structure the workouts on a day-by-day basis. But you know what? I think we can end it there. One more thing, we're going to be discussing this again. I know we've done one of our FRS ISMs, the internal strength model, at the University of California, Berkeley. We were at the UFC, at the UFC PI. The next place we're doing it is going to be at the University of Pittsburgh, April 23rd, 24th. So you can check out functionalanatomyseminars.com for that date, or for any future dates upcoming. Anybody else have anything else to add?
Nope.
All right.
No, I think that is a good segue into part 2, though, talking about
I think
the control of intensity, because that gets us into what gets us into continuing the volume problem as well.
Yeah, because I think we have to clean up some of the volume problem, and how to fix it maybe next time is a good.
Yeah, like because I think it's a good segue into talking about how intensity can be controlled to acquire what you need to acquire.
Brilliant. But as of right now, I'm out of coffee, which means we are out of time. So thank you, gents. We'll talk to you again soon.